Last week we had a look at the chi-square test, and I explained how the test worked, and we went through it from the graphs getting through to the output. This week I want to start working through a procedure for how we choose a test and then how we run the procedure to give you a bit more of a framework for how you'll go about working with your own data. And I've got the flowchart that goes along with this, obviously. So we're going to have a look at the mindfulness data, and here I've given us a question: is there a difference in the change of perceived stress for those participants who completed the week 2 activity, which was filling in this event awareness journal? So when we go through this process of choosing a test, we really need to know what our variable types are and how the experiment was designed. So in this case, the outcome that we're interested in is the change in stress, and this will be a continuous variable. And the explanatory variable just for this question is 2 independent groups, because we had those who filled in the event awareness journal and those who didn't. So even though overall it was a paired design and they had the before and after measurements, just for this particular question we're looking at the difference between the 2 separate groups. It was not a controlled experiment. This was down to whether participants chose to fill in this journal or not, is my understanding. So based on that information, we should be able to choose a test as a starting point from our flowchart. So on the flowchart, we would start with the outcome, which we pick from along here, and we've got a continuous outcome. We're looking at 2 independent groups, and so we would pick the independent t-test. Now this has some assumptions which go with it, and we would need to check these. I've written them briefly here, but I'll show you the web page as well that we're using for the assumptions. If the assumptions are not met, then we might need to what we might call fix the data, transform it in some way if possible, or we might decide to use a non-parametric test instead. And those 2 things we're not covering in this course, so hopefully the assumptions are okay. So we've chosen the independent t-test as a starting point. Does the data meet the assumptions? The assumptions are different for each test, and we're going to use layered statistics, so we've got a bit of consistency in how we're assessing these. So I'm going to link to the layered page here. Now there is a paid version of layered. You don't need to pay. We're just going to use the stuff that's freely available. So the first assumption, your dependent variable should be continuous, your independent variable should be 2 categorical independent groups. That's what we've got. You should have independence of observations. And this is down to the design of the experiment. So we can't really test this with SPSS, but we're going to assume that the people who participated in the study were more or less independent of each other. The next 3 assumptions are the ones that we would then look at using SPSS. So there should be no significant outliers, approximately normally distributed, and homogeneity of variances. So let's look at these one by one. The outliers, the easiest way to look at that is to do a box plot because the outliers show up. So let's go back to the data. So here we have the stress pre, the stress post, and the difference in the stress. If you have gone to the Dryad website to download the data, then you might not have this column because I think I made it, but it's been a little while. And you can use the transform compute variable if you want to make your own calculation. So you would just put in a new name like difference and then put in what you want it to calculate, like stress pre minus stress post. Click and OK, and that will create you a new column with that calculation in there for you. So this person started off at 28, 16 after, so that was a drop of 12. So that's our outcome, and then we want to compare the 2 groups, whether or not they filled in the event awareness journal. Now I've got a link to the Dryad website, and you can see here there is what we call a README file, and that's information about the file. So if you're not sure what some of the numbers mean, you can click on that README file and have a look. I've already had a look at that file, and for the event awareness journal we had 2 options. 1 was yes and 2 was no. So if you don't have those value labels in there, just pop them in now, and then that'll show up on your graphs and output. And the other thing that you might notice when you're looking through is that we've got these odd 88s popping up. And this is not listed in the README file, but my guess is this is just a missing data code. 88 is probably a little unusual as a number choice. Often you'll see 98 and 99 or 999. And to pop that in, just click on the blue dots, say discrete missing value, and just put in 88. Okay, so that's our data. Let's have a look at a box plot to see what the outlier situation is. I'll reset that. So we're going to do the box plot. We're going to look at the difference in stress, and we're going to compare between whether or not they completed the journal. Okay, we do have some outliers. They don't look massive, so I don't think they'll be having too much of an effect on the mean. What outliers can do is they have the effect of pulling on the mean. We can't see the mean on the box plot, we can only see the median. But if we found that there was a significant difference in a case where we have outliers, then we would have to interpret the results with a bit of caution, because it could be the outliers that are having a pull on the mean. In this case, I don't think it's going to be too much of a problem. There's only 3 of them and they don't look too massive. I don't think we're actually going to see a difference at all between these 2 groups. So it's not an absolute assumption. It's not like you can't have any outliers. It's just you have to be careful that the outliers aren't having too much of a pull on the mean. So the next assumption is that the dependent variable should be approximately normally distributed for each group of the independent variable. So the easiest way to check for normality, we can run a test for it, but I think it's probably better practice just to get used to looking at your data and making a judgment call, and then you could move into the testing later if you need to. But let's just do a graph. Now, we can do a histogram through the chart builder, but it's a little tricky to get it split into the two groups. You can do the stacked one and you can do the population pyramid. I don't particularly like them. You can use them if you want. So let me show you another alternative. We're going to go to graphs, legacy dialogues, and histogram. And this is probably the only time I wouldn't use the chart builder. I'll just reset it so you can see what I'm putting in. The difference pre and post, I'd like to see the normal curve and the journal as the rows. And you can see now we get the 2 rows for journal yes and no. We can see the outliers here, which we could see on the box plot. It's mostly normal. It's normal enough. We've got a little bit of a peak here, but that would probably even out with this one here if we changed the binning a little bit. So I'm going to say that's approximately normal. It's unlikely that you would get any data that looked perfectly normal, especially if it didn't have a particularly large sample size. So the last assumption is that there needs to be homogeneity of variances. Now again, there's a test for this. So just looking at the data, you'll probably get a feeling for, is there a similar amount of variation in the 2 groups? And it looks like there is a similar amount, although I don't know what effect these outliers are going to have. But this is something that SPSS will test for us when we run the independent t-test. And if the assumption, if there's a problem with the variances, it actually gives you 2 versions of the test, one where you assume the variances are equal and one where you don't. So that wouldn't actually stop us from using the independent t-test, we would just use a different version of it. So if we go back to this process we're going through, does the data meet the assumptions? Yeah, it sort of does. It looks okay. Can we use a different test? Possibly you could use the non-parametric test if you were worried about the effect of the outliers. I'm going to say that this is okay. So if we've chosen a test, that's where we would then go through this hypothesis testing procedure. The null hypothesis for this test is that there is no difference in the means. So we're saying that there is no difference in stress for people who do or do not complete an event awareness journal. The alternative hypothesis is that there is a difference. In the textbook, they talk about setting a critical value for significance like 0.05. In practice, I think it's probably better to think about the strength of the evidence, and this is the sort of guide I've given you, that up to 0.05 we might say there's moderate evidence, then strong evidence, and when we get close to 0 we would say we've got very strong evidence. Calculate the test statistic and the p-value. So that's where we would run the test. You can do this by hand, you can look up the formula if you want. We're just going to use SPSS. So analyse, compare means, and we're using an independent samples t-test. Our test variable is the difference in stress. Our grouping variable is the journal. Now the trick here, I say trick, the irritating thing you have to do here is that you have to actually say what your codes were, and they were 1 and 2 in this case. Continue and press OK. So let's look at the output. I'm going to select those cells and I am going to colour them in, let's go green. Now, the reason I'm colouring them is because these are actually not the t-test. This is the test of variances I was saying before that we can get if we're trying to work out if the variation is similar. The null hypothesis is that there is no difference in the variances, and we have no evidence against that. We've got a very high p-value here. So we can assume that the variances are equal. So that would mean we use this first row where we say assume equal variances. Now what you'll notice in practice is that there's often not really a lot of difference between the p-value depending on which version of the test you use, and I can see that here. There's not a huge amount of difference. So the null hypothesis is that there is no difference in the reduction in stress based on whether or not you completed the event awareness journal. And we have no evidence against that, so the significance is here. We're looking at this box. And so, I changed the font instead of the background. That made it even harder to see. That's all right, 0.32. So we have no evidence against the null hypothesis, and therefore we have no reason to believe that there is any difference in the reduction in stress based on that one activity. So we would make a statement about the evidence and then write a sentence summarising the results. So I'll put that into the answer sheet when I do that. And if you were reporting this test for a student project, you'd probably put in some of these graphs to show that you've checked these and talk about the assumptions. In practice, when you're reporting in a journal, this kind of stuff usually gets skipped just because there's not enough space to cram all this stuff in, and it can get a little bit repetitive if you're doing loads of things.